right, guys, here is example 8. Sorry there's a little bit of writing. I just did it, but I wasn't filming, so sorry. It stinks. So, let's see this. It says, a pile of sand, a sand is poured on a beach, creating a cone. Okay, so we haven't seen cones yet, so we might have to brush up on our cone formulas, but that's the shape that we're dealing with. And it says that its radius is always equal to twice its height. And so what that means is that r is equal to twice its height, right? So that relationship might be important later. Then it says, if the sand is poured at a rate of 20 inches cubed per second, how fast is the height of the conical pile changing at time the height is 2 inches and 6 inches? So I've got a cone, and as a reminder, a cone looks like this, right? Has some radius r and some height. Okay, now I'm going to draw a separate cone just so we can understand what's happening here. We want to know always what's given to us, right? So we want to know. So it says 20 inches cubed per second. Cubed should be a huge hint. It says if the sand is poured at that rate. So sand is being poured and it's accumulating like this. So what's really changing here is our volume. Okay, so they gave us dV dt to be equal to 20 inches cubed per second. And again, the cubed should be a good indication that you're dealing with volume. All right, and then it wants to know, so what do we need to find? It wants to know how fast the height of the pile is changing. Okay, so that means we want to know the change of h. Now, change or rate, we should be thinking derivative, so we're looking for dH dt, right? And we want to know what that is when its height is for part A when h equals 2, and for part B when h equals 6 inches. Okay. And then the last step here is our equations. Okay. Now again, since we're dealing with volume, the thing that's going to relate all of this is our volume formula, and this is something you might have to brush up on. But that is going to be volume equals 1/3 pi r squared h. Okay. Now, in the context of this problem, we actually can make finding the derivative of this a little bit easier and turn this into just having one variable instead of two, where we'd have to use the product rule because of this relationship they told us, r equals 2 pi. Plus, they don't tell us anything about radius, so we got to get rid of that. So instead of writing r squared here, what I'm going to do is substitute r squared. I'm going to put r 2h there, okay? And so what I'll get is 1/3 pi 2h squared times h. And if I simplify that even further, we get 1/3 pi. Well, 2 times 2 is 4. H times h is h squared. So 4h squared times h. And then I'm going to move this 4 over here to the numerator, so 4/3 pi. And then h squared times h will give me h cubed. And that's my volume formula, right? That equals V. But I'm looking for dH dt, so the only way I'm going to get dH dt is if I take the derivative of this, right? And again, this is equal to my volume. Okay, so if I take the derivative, I'm going to get dV dt, right? Derivative with respect to time is, now again, power rule. Bring this out to the front, it'll be 3, and those 3's will cancel. So 4 pi h, now subtract 1. Okay, and then with respect to time, so dH dt. Okay, and that's good because that's what I'm looking for. And then it becomes a simple plug and chug problem from here. So if I have my part A, my dV dt they gave us is going to be 20 equals 4 pi times h squared. Okay, well, h is in part A 2. Okay, and then times dH dt. That's what I'm looking for, right? So this is not so bad. 2 times 2 is 4. 4 times 4 is 16 pi dH dt, 20. So dH dt is going to be equal to 20 over 16 pi, okay, which you can simplify. I don't know. It doesn't matter really unless you're in multiple choice. But I'm just going to put it in decimal form. It's going to be 1.59 Did I do this right? I'll just do it. 20 divided by 16 pi. I feel that I made a mistake. Those cancel. I get 4 pi h squared dh dt. So we know that this is 20. 2 times 2 is 4. 4 times 4 is 16, right? Okay, cool. So you get 3.927, and it's going to be in inches per second. Okay, and then we repeat that process for part B. Okay, doing the same thing here. And what we get is still a rate volume of 20, right? dV dt is still equal to 20. And then we've got 4 pi times h, 4 pi times h. In this case, for part B, h is equal to 6. So 6 squared times dh dt. Okay, well, 6 squared, right? Keep the pi. I don't care how you do it. Let's just do 20 equals, I'm going to do 6 squared times 4, right? So we get 144 pi dh dt, and then when we divide dh dt, let's say we get 20 divided by 144 pi, and we should get 0.4363. Okay, and let's do at least 3 decimal places. That's how the final exam likes to do it. And then it's inches per second. Okay, beautiful. And those are all of, well, we've got one more. Okay, so that's example 8.